Michael went to the driving range with his rangefinder and hit 75 golf balls with his pitching wedge and measured the distance each ball traveled. So I guess that's what the rangefinder does, is it measures the distance that each golf ball travels. Okay, it says the accompanying table shows his data, so that's going to be within here. For part A, we're asked to construct a relative frequency histogram, and we're going to use technology to do this. So let's open up this table. So here we have the 75 golf balls that were hit and their corresponding distances traveled. I'm going to open this data in StatCrunch. I can close this now, I don't need it. Going back into StatCrunch, in the first column, it's like for his first hit, compared to the second column is the distance that it traveled. So the actual distances are in the second column, and the first column is just telling you was it the first, second, third, or fourth, or so on. To get a relative frequency distribution, that is a histogram. So I'm going to do this by going to Graph, selecting Histogram. Okay, from here, I know all of the data was in the second column, so I'm going to choose var2. And down here where it says type, I don't want a frequency distribution, I want a relative frequency distribution. And that's it. I can click compute, and it will get the graph for me. Okay, and all I need to do next is compare this to the correct choice, either A, B, C, or D. Well, to start with, just something to look out for. I'm noticing that options B and D, if you look at the Y scale, go from 0 to 25. A relative frequency should be a probability, so a number between 0 and 1. So like immediately we're eliminating these two options. It could only be A or C because the scale for these two go from 0 to something that's less than 1. So let's choose the correct one. So for this graph, it seems to resemble A more than it does B. So I'm going to go with choosing A. Okay, great. The next thing is comment on the shape of this distribution. So the idea is this thing a normal distribution? Does it have no pattern? Is it uniform? If I go back to this distribution, uniform would be a horizontal line, and clearly this graph doesn't do that. It kind of goes up and then it goes down. And there does appear to be a pattern to it. I would say that this is normal in that it has a bell shape. It's not perfect, but it starts low, it reaches a peak, and then it drops back down again. Again, not perfect, but close enough to say that this thing is approximately a normal distribution. So I'm going to choose B. For the next part of the problem, it says to, since we've decided that this is in fact a normal distribution and relatively bell-shaped, can we draw what that curve would look like over the distribution itself? So looking at the information, clearly it's not going to be C or B. A horizontal line would represent a uniform distribution, which this isn't. Like, this does not match the data set at all. If you look at A and D, okay, those are pretty good, but there's, again, already a problem with D, and it's the scale. It shouldn't go from 0 to 25. It should still go from 0 to a number less than 1. By process of elimination, okay, we have that. It's got to be choice A. But you can actually do this in StatCrunch too, and I'd like to show you how to do that. So since I have this graph already open, I'm going to go to Options and click Edit. This takes me back into what we did to get the distribution the first time. So we selected var2, the type was relative frequency, but there's this other option called Display Options, and it says to overlay a distribution. You can choose to put a normal distribution over your data that closely matches the data set. It's a way to visually see if you think your data is normal or not. So all I did was switch it from optional to, okay, I'm going to go to normal. If you click compute, it puts a bell-shaped curve over the data. So this resembles this option here. So I'll click check answer. Okay, and part B says, do you think the normal density function accurately describes the distance Michael hits with a pitching wedge, and why? So I'm going to say yes. If your data is relatively normal, then it can be approximated by a normal distribution. So it's not going to be no, it's got to be choice A or B. The answer is yes. I just want to choose the right one. If I look at A, it says yes, because the distance Michael hits the ball is a random variable, so it is normally distributed. I don't think that's really addressing what's going on here. I don't think that's going to be it. Let's see what B says. So again, yes, because the histogram shape resembles a normal curve, and the area under each bar is roughly equal to the area under the normal curve for the same region. So like if you look up at this picture here, this data, it's not perfect, but it almost fits underneath the bell-shaped curve. So it means that the two are really similar to each other. That is what B is trying to convey. I'm going to select B, check my answer, and that was correct. So that is everything for this question.